everyone, in today's video we are going to explore one of the most important types of neural networks, recurrent neural networks or RNNs. And if you are aiming for job roles like data scientist, machine learning engineer or deep learning engineer, then RNNs are the module you need to know. In today's video, we will explain how RNNs work and why they are so powerful for tasks where the order of data matters. And by the end of this video, you will have a good understanding of how RNNs can be used in real-world tasks like speech recognition or stock predictions. And also, if you're excited to dive deeper into AI/ML, don't forget to check out our free masterclass on AI/ML and Agentic AI. It goes just beyond RNNs. In the masterclass, we discuss the proven 3-step framework and the exact roadmap to land a high-paying job in the field of AI and machine learning. Professionals like Utkarsh, Shrija and Debashish have used these techniques to land great jobs in top companies. The registration link is right there in the description as well as in the pinned comments. So now let's jump in and get started.
But I'll just give you a brief about what is RNN. Okay, so it is a type of neural network which is useful for text, speech or time series data. I'll give you an example. A very simple example. You go to any stock market. How do you purchase the stock? Based on the last performance of the stock, right? Yes or no? Generally, when you purchase a stock, what is your trend? How do you see? You do see the overall performance, but when you want to, maybe you are doing an intraday. So how will you perform the task? Based on the maybe the last day performance, correct? Right? In this case, you could use neural network. Okay, recurrent neural network was used for time series, speech. Okay, when I talk about speech, again, we do look for the sequential information because we want to convert the text into maybe another language or maybe do a speech translation, right? So recurrent neural network are something which are able to you can say have a context with respect to sequential data. Okay, another thing that we need to understand about recurrent neural network, let me just take this sentence. There is a sentence called as I love llamas. Okay, now I want to convert this sentence into maybe a Dutch, or maybe I want to convert it into French. Okay, so if I want to convert it into French, this is how it should work. Ik, how, when, llamas. This is the word. Wherein actually love, okay, is actually a two-word representation in Dutch. It's not just one love representation, one word representation. Okay, maybe I want to do this kind of translation. Recurrent neural network were able to do this kind of translation, but they were not able to do translation for long-term dependency. You're getting? So if you have lot of data and you want to do translation, okay, then it was failing because it was struggling with long-term dependency. Okay, that means it was not able to retain the information for longer time, because of which it was able to do small task translation, but it was not useful for doing long-term translation, long-term dependency translation. One of the tasks. Training was slow, and you can say this was right now it is being replaced by, there is something called as long short-term memory and GRU, but that is actually replaced by right now with transformer. Okay, now what is transformer? Let me just help you understand with this example. Okay, if I want to do translation task with attention using RNN, how was it working? I'll just give you an example. So I have a sentence. This is with respect to RNN I'm explaining it, and then we will see the similar kind of task if I want to do with the transformer and self-attention mechanism. How does it actually work? Okay, now I have a sentence which is I love llamas, and I told in Dutch it is ik, when, llamas. This is how you write in Dutch, and I want to do this kind of a task. Now, before we look into this, we need to understand what is attention. Okay, I'll give you a very simple example with respect to attention, and that will be more useful for us to make sense. I'll just give an example. Have you all seen a movie? If you are an Indian, you must have seen Andaz Apna Apna. Have you seen the movie Andaz Apna Apna of Salman and Amir? I hope all of you must have seen, right? Now, my point is, when I saw that movie in 2000, I was a child in 2000. I saw that movie once, okay, only once. After that, I have not seen that movie, okay. But still, if you ask me anything about the movie, I'm able to make sense out of it. and I'm able to tell you verbatim sentences and dialogues that were being used in that movie. The reason why I'm able to do that is my mind is able to capture what I saw in that movie more efficiently. Okay, so there is something that has happened which is still there in my memory. Okay, maybe I attach more weight when I was seeing that movie, so that it left impression on my mind, and still I'm able to recall. On the other hand, I met a person 4 months back. Okay, just 4 months back, I met him, and I'm still trying to recall when did I see him, or where did I see him, and what is his name. The reason is I did not pay attention to that, and that's the reason I'm not able to recall it. So attention is a very important thing that we need to understand. Attention depends not just how many times have you seen the person, it also depends on whether the weight was being attached to that person, or maybe to that movie, okay, or maybe to that sentence. Is that making sense what I'm saying? So it is important that we have lots and lots of repetition. That does help. Okay, maybe duplication will help, but general point of attention is being able to give more meaning to a sequence of event as compared to other. That can help us have more attention. Okay, I'll just try to explain. So attention allows a model to focus on part of the input that are relevant to one another. Maybe I was able to correlate to that movie more than any other movie. Okay, so that was more relevant to me as compared to any other movie. Okay, so I'm just helping you understand attention. Attend to each other and amplify the signal just to help you understand. Before that, let us just take this example. So, how does attention work? So basically, you first, whatever RNN, how does RNN take this into picture? So if you remember, we have an RNN, right? RNN actually takes the whole input and then outputs the one token at a time. That token can be a word or it can be a letter. I hope now we are clear with what is token, guys. We are clear with token, right? It can be a word or it can be a letter or it can be a sentence. Is it okay? So the moment RNN sees this sentence, it outputs one word. After outputting that one word, in the step 2, RNN takes the input and what has been outputted to output another word. Then RNN takes input and those two output tokens to output another token, or you can say word. I would represent it as a token to make it so simpler. And that's how it is actually going to come to a logical conclusion. Okay. Now, when it does this, actually what it uses at the back end is, I love llamas. This was the sentence, right? So at the back end for I, love, and llama, RNN uses something called as word-to-vec embedding. Google has already created word-to-vec embedding, wherein there is a token ID associated to each word with a embedding representation of that word. Now, I'll just try to stop the things and ask you, what is embedding? It's not tokenization of the word. It's not tokenization of the word. It is the representation of the token in a mathematical thing. You remember? It's not just tokenization of word. Tokenization has already happened. If it is a cat, and if this is first time, suppose word2vec does not have cat thing, then it will consider CAT as 3 token. But then it will take C and represent C as a set of feature which is called as dimensional representation in the mathematical space. Is this okay now? When we say embedding, it is not token. This is actually my token. I am saying my each word is a token. I have already told this. Each word is a token and this can change. Is it okay? Do not get confused with token and word. Keep it simple. Okay, so right now when I say token, I say one token is equal to one word, or one word is equal to one token. There can be a sequence wherein one word can be equal to hundreds of tokens. That's fine. Is it okay? If the word is of 100 character and suppose each word itself does not have any representation separate together with any other word, then it will be represented as a single token. Is this okay now? So each word to vec embedding will be a vector representation of each word. It goes through a RNN. RNN has two things, encoder and decoder. It goes through an RNN. When it goes through an RNN, it tries to find similarity between these words. Okay. it is trying to, it will represent the vector. So this is vector, right? It will try to find vector similarity between words, like how these words are similar to each other. And this is where it creates something called as context embedding. Again, I'll repeat. Context embedding basically means if there are three words, it will say, I'll give you an example. Suppose if this is equal to 1 and this is equal to 3. So now now tell me, llama is more related to, like, if I want to, like, just to help you understand, if I want to give a more meaningful representation to this llama, maybe I'll say 3.5 something. I'm just giving an example. So what I'm trying to help you understand here is, this is 3.5. Okay, so what I'm trying to help you understand, each word is actually represented, each whatever is there here will be represented as a context embedding. Okay, now what is context embedding? That means this, just see this. What is this? I'm trying to draw a matrix wherein I have I love llamas. And suppose I already know ik, who, when, llamas. Suppose this model has already seen, then only the model can translate, right? So just to assume, suppose these are the words, and there are many other words also. Maybe there is a word called as Jalal also. We are okay to put it. Let me put it. Okay, so there is another word here in the German dictionary. Maybe Jalal is there. Maybe Atul is there. Suppose these words are also there. Assume these 6 words are available, okay, at the time of translation of I love llamas to German. So that basically, if I want to do translation, that means this model must have seen Dutch, right? Correct? Who gets the job of translator? The person who knows the language, right? Everyone agrees? Who gets the job of a translator? The person who knows. So right now I have just put 4. Suppose there are many words, okay, I'll just put it this way, there are many other words that were part of my RNN network. So suppose there is one word that is there, let me just put it here. There is one word called as Jalal, there is one word called as Atul, there is another word called as Pranjal, maybe, just helping you understand. Okay, these words are available. Now what is going to happen? Now tell me, I and Jalal, okay, will have some measure, right? Now, if I'll put it this way, now if ik is equal to, this ik also has a vector, right? It has a vector, and this I is also a vector. Tell me, which vector will be more similar to each other? V1, V2, or V1, V3? Tell me. You don't know, the model knows. You're getting the point? Model is just looking at embedding and comparing. You're getting? Making you understand there can be hundreds of words. What the point is, whatever you want, it will look into the dictionary to find the relevant thing and give you a score. Okay? And the best score it will pick up and give you a translation. So if I say I is equal to Jalal, no, it's not. We also know, but the model, how will it know? It will know by looking at the embedding value of Jalal in German. You're getting? Trying to keep it simple so that it makes more contextual sense to all of you. There are lots of things that we are going to say. RNN was being developed locally also by many teams, right? For their set of things for small sentence translation, RNN was being built, wherein just to help you understand, you go to a Google translator, right? You try to output something. If it is a huge translation, you will see it will falter. Google Translator. Go for a small translation, you will see very good output coming out of it. Okay, and if you use maybe a Microsoft translator, then you will see different words popping out as compared to Google Translator, but both will make sense to you. And then it's up to your choice, right? Which one do you want to take it? You're getting? Generally, it will represent the closest word, but again, synonym can be a problem if the embedding is not capturing the things appropriately. So it's all up to that embedding. Yeah, that is where I'm saying it is having semantic thing. It is capturing those semantic thing only. That's the reason when this I and ik met, it saw a very blue color. Okay. When it say how and love, it saw love giving more weightage, even when and love is also part of it. But if it had to output love, it will first output how and then it will output when. Basically, both are together. But in the German dictionary, it is not considered as a single word. So when it will output I love llamas, it will say ik, how, when, llamas. For the first word representation of love, it will take how because it has more attention. You're getting? And then it will output when because it has less attention. Okay, if I just want to put it this way, I love llamas, then it will take this kind of a sequence wherein it will output the words based on the similarity. Just to put it this way, this is what I'm saying. So I have just to put it this way, I have an encoder and I have an attention decoder. This is where I say attention. It makes use of attention. Words with similar meaning will have more weights since they are highly related. Okay, and after generating the words, okay, the attention mechanism, so actually it will keep on generating words, right? So it will generate ik, okay, then how, then when, and how is it generating? This way only. So what it is doing, it is attaching this word and the whole sequence is again passed to the RNN network. When it goes through the RNN network, after ik, it finds that how should be the most appropriate word. Okay, then after it passes how, then it will again pass the whole sentence and it will say after how, I think when is the most relevant word. And then it will take this and maybe it will take llamas. I'm just helping you understand. Okay, so it is taking everything together. And now the point is when it is taking everything together, the context, long context I told, right? So if it is a huge translation, then it may lose the context of this, right? Because of which it can output some weird word which is not relevant. It can do that. You're getting my point? Okay, that can also be one of the things. Just helping you understand how does it function. It takes one word at a time, and we know what is the struggle, right, with RNN. I told you, first of all, it does take a lot of time. Okay, long-term dependency is an issue wherein it can forget the previous words because it does not have that retention mechanism, okay, to an extent that it can retain long context, but it can do a fairly good work with respect to small translations or small tasks that we want to perform or small language tasks that we have. Let me put it this way. Now my sentence is I love llamas. Ik, who, when. This is the sentence, correct? I told you in the last sequence, this will be the sentence, right? Yes? You're getting the point? Now tell me, if I want to predict the next word, I want to know this next word. Understand what I'm saying? If I want to predict the next word, okay, let me say ik. Now tell me, which word will it pay more attention to get the things for the next? You're getting my point? Out of all this sentence, all these words, try to understand what I'm saying. Put it this way. Okay. So what I'm saying is a very simple thing. Out of all these words that are right now seen, to predict the next word, which word will it give more attention now? Tell me. Llama. So that means the output, the value that I will have for llama here will be far more than any other value, right? It will be the highest because now it knows to predict this word, out of all the sentence, llama should be given most priority. You're getting my point? When this was the case, to predict this word, which word would have been given the most importance? Tell me. Ik, right? Ik. And after ik, which word would have been given the most importance? I would have been given importance. That's the reason ik came. Then after I love llamas ik, just look at this sentence. I love llama ik. To output the next word. What I'm saying? To output the next word, I love llamas ik. You know that how should come, right? So which word will be given the most importance out of all four? Love. Okay.
So today we have learned about recurrent neural networks, RNNs, and how they handle sequential data like text, speech, or time-based information. We also looked at some examples of how RNNs are used in the real world, like in stock market predictions and language translation. So now it's your turn. Try building a simple RNN model on your own and see what you can create. If you have any questions or need help, feel free to leave a comment below. We are here to support you. And don't forget, if you want to learn more, sign up for our free masterclass. It's a great way to level up your skills and boost your career in AI and machine learning. Also, if you enjoyed this video and found it helpful, hit subscribe for more easy to understand content. Thanks for watching, and I'll see you in the next video.